not a family member. What regulates the growth of fat cells in the human body? Any young person, can they tell me? Just try. Okay, let me ask this way. What regulates growth in the human body? What biological agent, what do we call it? Something that regulates growth?
Insulin.
Hormone?
A hormone. Very good. So for example, my son is growing because of the action of growth hormone. And that action of growth hormone causes him to eat. So he eats because he's growing. He doesn't grow because he eats. We've got the reasoning back. Can you see? He is eating because he's growing. In other words, growth hormone is directing the biological behavior called eating. Asad, brother, it is insulin. Insulin is the hormone that regulates your fat tissue. If you've got a problem with weight, if you want to get your weight under control, if you want to be slim, you have to get your insulin under control. This is where it's at. So let me guide you through it. This is what insulin does. I wish I had a pointer. So that's your blood on the left-hand side, and the black circles represent glucose or blood sugar. So you eat a meal, and the level of sugar in your blood goes up, right? But that sugar isn't designed to stay in your blood for a long time. That sugar is designed to be transported from your blood into your cells, so your cells can get nutrition. What insulin does is, insulin is the chemical messenger that goes to the door of the cell, knocks on the door and says, I've got glucose, I've got energy, let me in. Insulin unlocks the cell so the cell can receive glucose. And when the cell receives glucose, what happens to the level of sugar or glucose in the blood? It comes down, right? Insulin is very important. But when the cell has had enough glucose, it can't take it anymore, it's had its fill, the cell says stop. It puts up a no vacancy sign. I can't take any more. If the cell was to take more glucose, it would become damaged, become packed with too much sugar. So the body or the brain says we've got a problem. The cells can't take any more glucose. In this case, it's your liver and muscle cells and other body cells. But we've got all this sugar in the blood. What are we going to do? Because it can't stay in the blood. I'm going to explain why. It's very dangerous. So the body then goes to plan B. We can't shift it into the liver and muscle and other body tissue. We're going to shift this glucose. We're going to take the glucose and shift it to where?
Fat. The fat cells.
Ahsan. There is an unlimited ability of the body to convert glucose into fat via insulin. Insulin is the hormone that converts sugar into fat. Memorize that. That's a biochemical fact. You can't argue with that. Insulin is the hormone which converts excess sugar in your blood that your body doesn't need into fat. So who can tell me how we get fat? Insulin. Okay. Are you following? Am I clear? So that's your blood sugar levels have dropped there. Because it's gone into the cell and it's been converted to fat. Now notice what happens when your blood sugars drop. Because you've got too much blood sugar in your blood, it's gone into your cells, it's gone into your fat, and your blood sugar has now dropped. How do you feel when your blood sugar is low?
Tired.
Tired and?
Hungry.
Hungry. So what do?
Eat more.
You eat more. And you're probably going to eat more of the foods that started this whole process. You're not going to go and eat salmon with a butter and garlic sauce or some nice veggies. What are you going to eat?
Twister. KFC.
KFC Twister, bag of Doritos, right? Probably. Something that will satisfy the biological drive for the blood sugar to come back up. Bear with me, I'm going to take you somewhere. Let's follow the logic. I believe this logic is, can't be argued with the way that it's laid out biochemically. Number one, obesity is a disorder of excess fat storage, no doubt. Calories are not part of the biology. They are a behavior associated with a dysfunctional biology. Fat cells are in permanent fat storage modes. They're growing abnormally. Fat storage growth is being directed by a hormone called insulin. What's the next logical question to ask?
How do we lower the insulin?
How do we control this?
How do we control it? Have a think about it. What's the next logical question you'd want to know, now that we've talked about insulin so much?
How do you make it stable?
How do you make it stable? It's actually, what raises insulin levels? Wouldn't it be nice to know? What's triggering all this insulin being released? What raises insulin levels in the body? What triggers your pancreas to release insulin into your bloodstream? Let's consult a biochemistry textbook. Don't believe Abdul Hamid Saad. I'm not medically qualified, which is true. Medical Biochemistry, Human Metabolism and Health and Disease, published in 2009, pages 163 to 164. Fatty acid synthesis just means the creation of fat. Fat cells, fat tissue in your fat cells, is most active following a meal, after you eat. In the first few hours after foods containing carbohydrates such as starch, cereals, grains, bread, rice, pasta, and sucrose, sugar, have been digested and absorbed, the body experiences a period of transient hyperglycemia, high blood sugar, which triggers insulin. Sorry, brother, can I get some water, please? Which triggers insulin from the beta cells of the pancreas and suppresses the secretion of glucagon. I'm not going to go into glucagon, we can talk about that later, but basically when you eat carbohydrate, your blood sugar level goes up. When your blood sugar level goes up, your body wants to clear that blood sugar from the bloodstream into the cell. So insulin is released. The resulting high insulin level triggers hepatocytes, liver cells, and adipocytes, fat cells, to take up the glucose, the sugar from your blood, and convert it into fatty acids, into fat, and ultimately into triglycerides, a form of blood fat. Fatty acid synthesis is thus greater when a person is consuming a, what does it say? A high carbohydrate diet than a diet that is relatively low in carbohydrate. What did the food pyramid tell us to eat? 6 to 11 servings a day. Sounds like there was a recipe to make us all fat. Maybe this was designed by some evil genius. Because this is fundamental biochemistry. Cannot argue with it. This is how Allah subhanahu wa ta'ala has designed the body. This isn't opinion, this is fact. You can confirm it. This is what raises insulin levels in the body. Sugar, bread, rice, pasta, cereal, grain, cakes and pastries, Coca-Cola, rice, carbohydrate. So we've got 3 macronutrients. Macronutrient means a nutrient. Sallu ala Muhammad wa A macronutrient is a nutrient that your body requires in large amounts. That's what macro means, large versus micro, small. We've only got 3, carb, protein and fat. Very simply, carbohydrates are a quick source of energy. Your body very quickly breaks it down into sugar. When you eat a piece of bread, when you eat wheat bix, when you eat grains, that is metabolized as sugar in your bloodstream. Even though the packet of wheat bix says 0 sugar, in your bloodstream that's going to become sugar. That's a carbohydrate. All it is its sugar molecules linked up, bound up together, and your digestive system just breaks up the bonds and masses of sugar are released. That's what happens if you have a bowl of rice, cereal, or if you have sugar in your coffee or tea or in a Coke. Protein is not a very good source of energy for the body. Protein is more structural, it's for support, it's for rebuilding. Rebuilding, repairing DNA, rebuilding bone, hair, cells. Okay? Critical. Fat is actually unique. Because fat is a source of energy, like carbs, but it's also a very critical source of insulation for every single cell of your body. Every single cell in your body has a fatty membrane. The backbone of your cell is made up of